Hello everyone, this is Dr. Sunita M, working as an Associate Professor in Marri Laxman Reddy Institute of Technology and Management. Today I am here to explain few topics about our regular expressions. As already we have studied about a finite automata, that is DFA and FA in the previous classes. So today we will study about a regular expressions. Okay, what is regular expressions? Regular expressions are symbolic notations used to define search patterns in a strings. Okay, they describe regular languages and are commonly used in tasks such as validation, searching, and a parsing. What are the components of a regular expressions? That is basic symbols. What are the basic symbols here? So alphabets, strings, empty set, that is alphabets. So what are alphabets? Single characters from the language is nothing but called as alphabet, that is letter A or B or C. Okay, empty string. Okay, there is no string, that is representation with which is represented with a epsilon, and empty set, that is represented with a null set. Okay, and what are the operators we are going to represent in a regular expressions? That are union, concatenation, clean star, parenthesis. Okay, union A or B. So that is languages which include strings from either A or B. Next, concatenation. Okay, A, B. Okay, strings formed by concatenation strings from A and B. Clean star, that is A star. A star indicates what? Zero or more repetition of a strings from A. Okay, one or more times. Okay, A star indicates one or more time, or else it may be zero also. Parenthesis, used for grouping. Okay, example, that if A or B is there, whole star, how we need to represent whole star for A or B? So we need to use a parenthesis. Okay, these are just a few operators we are going to use in a regular expressions. Okay, so a regular expression represents a regular languages if it follows these rules. Okay, there are some rules which need to be followed. Okay, epsilon is a regular expression which is represented by language as a epsilon here. Okay, we need to represent like this, epsilon. Any symbol A from the input alphabet, that is sigma, is a regular expression which is represented the language A. Union of A plus B, how we are going to represent, is a regular expression if A and B are regular expressions representing the language A comma B, union. Okay, next, concatenation. A dot B, that is AB is a regular expression if A and B are a regular expressions. How we are going to represent in a concatenation? Union. Okay, next, clean star A is a regular expression whole star, meaning zero or more occurrence of A. Okay, forming a regular language. So these are just representations. Okay, so applications of a regular expressions. So regular expressions are a very powerful tools for pattern matching, text manipulation. They are used across various domains in software development, data processing, and computational tasks. Okay, like text processing, it is also used in a text processing, programming and development, data mining and cleaning, web development, network and a security purpose also, file handling, database queries. So these are few applications of a regular expressions, okay, which are commonly used. So identities of a regular expressions. Okay, so here what we call this as null. Okay, plus R is nothing but what is equal to R. Okay, null plus R is equal to R. So null plus R into null is nothing but what? Null set. Okay, next, epsilon into R is nothing but what is equal to r into epsilon or is equal to r. Next, epsilon star is nothing but what? 0 or more occurrence. Okay, star indicates what? 0 or more of occurrence of that particular number. It may be 1 time, 2 time, or n number of times, or it may be a 0 also. So epsilon star indicates what? Epsilon, or null star indicates what? Epsilon only. Okay, next identity is r plus r is nothing but what? Is equal to r. R star into R star is equal to what? R star only. R into R star is nothing but what? R star into R. Next, R star whole star is equal to R star. Okay. E, now that is epsilon plus R into R star is equal to what? Epsilon plus R star R is nothing but what is equal to R star. Epsilon plus R star is nothing but what? R star. So P into Q whole star, P is nothing but is equal to what? P Q into P whole star. Okay, this is one identity. Next, one more identity is what? P plus Q whole star is equal to P star Q star whole star, or P star plus Q star whole star. Okay. Next, P plus Q or R is equal to PR plus QR, and R P plus Q is equal to RP plus RQ. So these are few identities which are used to solve the problems. Okay, we should have an idea of all these identities. Then only we can solve the problems. Okay, we'll solve a problem now. So see here, this is a problem. 1 plus 0 0 star 1 plus 1 plus 0 0 star 1 into 0 plus 1 0 star 1 whole star 0 plus 1 0 star 1. That should be proved as equal to RHS, that is 0 star 1 0 plus 1 0 star 1 whole star. So how we will solve this problem? We'll solve this problem using identities. Okay, first let us take LHS. Okay, that is 1 plus 0 0 star 1 plus 1 plus 0 0 star 1 plus 0 plus 1 0 whole star 1 whole star 0 plus 1 0 whole star 1. Okay, this is LHS and we need to prove that is equal to RHS using identities. Okay, let us solve now. See here. Okay, what is common among this? First let us see these two are common, right? So we'll take that as 1 plus 0 0 whole star 1. Okay, nothing is there left there, so epsilon 0 plus 1 0 star whole star 0 plus 1 0 star 1. Okay, this is left now. Next, keep this as it is. Now check here. See epsilon, just see this expression. This is of which type? Okay, so 0 plus 1 0 star whole star is there, 0 plus 1 0 star 1 is there. So R star, that is, we can take this as R star and this is R. So what is the identity is? Epsilon plus R star is what? Nothing but equal to R star. So here R star will take 1 plus 1 0 star whole star, right? Next, okay, what is common among these? 1 is common. 1 epsilon plus 0 0 star 0 plus 1 0 star whole star, right? Epsilon plus 0 0 star is nothing but what? Epsilon plus R star. So this is nothing but what? Again R star only. So 1 0 star into 0 plus 1 0 star 1 whole star, right? Okay, but in RHS what it is, 0 star 1. So we can just rearrange 0 star 1, 0 plus 1 0 1 whole star, which is equal to RHS. Yes, right? So this is how we need to solve the regular expression using identities. So which identity we have used here? Epsilon plus R star is nothing but is equal to R star only. See here, LHS we have taken, okay, and we need to prove that is equal to RHS 1, and which is common among these two we have taken first, okay, and left is epsilon plus this. So this is what R star R, and epsilon plus R star is nothing but what? R star. So hence this and this R star we have taken. So again in this, which is common, is we can make this expression in the form of a R star, right? Epsilon plus R star, because 1 is common. So 1 we have taken a common here, epsilon plus 0 0 star. So this we have kept as it is. So 1, this is again what in the form of epsilon plus R star, which is nothing but is equal to what? R star, right? So 1 0 star, and this we have kept as it is, 0 plus 1 0 1 whole star. So this we have rearranged, 0 star 1 0 plus 1 0 1 whole star, which is nothing but equal to RHS. So we should have the idea of identities, this identities, right? So if we know all these identities, we can solve the problems. Okay, next one more problem we'll solve, that is epsilon plus 1 star 0 1 1 whole star, okay, into 1 star 0 1 1 star whole star, okay, which is equal to 1 plus 0 1 1 star. So just check this. Let us take LHS, okay, epsilon plus 1 star 0 1 1 star 1 star 0 1 1 star whole star. Just a simple example. Okay, what is this again? Epsilon plus, check this, same, right? But only here it is R star. So we can consider this as R star. This is R, this is R star, right? So epsilon plus R star is what? R star is nothing but what is equal to R star, right? Identity. So we can use this as R star, that is 1 star, okay, 1 star 0 1 1, wait here, right, okay, 1 star 0 1 1 star whole star, okay. This is R star we have taken now. Next we can take that is one more identity. What is the other identity? That is P star Q star whole star is equal to P plus Q whole star. Just check the identity. See here, P star Q star whole star is equal to P plus Q. Okay, we can use this in that form. So this we can take it as a P, and this will take it as a Q. P star Q star is nothing but is equal to P plus Q whole star. So P is what? 1 plus Q is what? 0 1 1, okay, whole star, right? So P star Q star whole star is nothing but what? P plus Q whole star. We can use this in that form. This identity we can use and solve the problem, and 1 plus 0 1 1 whole star we'll be getting. So what is this again? This is nothing but what? 1 plus 0 1 1 whole star, which is nothing but is equal to RHS. Right? So this is how we need to solve the regular expressions using identities. Okay, in the previous problem, just we have used is R epsilon plus R star is nothing but equal to R star, but we have taken one more example here with epsilon plus R star as well as P star Q star. See here. Okay, this is R star. We have got this expression. Okay, and again we need to simplify this, right? We can simplify this using which identity? P star Q star whole star. What is that identity says? P star Q star whole star is nothing but equal to what? P star plus P plus Q whole star. So here 1 plus 0 1 1 whole star. So this is nothing but what is equal to RHS. Okay. So these are the textbooks we need to refer for a regular expressions. Okay, that is Introduction to Automata Theory by John E. Hopcroft, Rajiv Motwani, or else Theory of a Computer Science, that is Mishra and Chandrasekhar, that is second edition, or else Introduction to Language and Theory of Computation, John C. Martin. Okay, or else John Willey, Introduction to Computer Theory, a textbook of Automata Theory, P.K. Srimani. Okay, Cambridge University. Okay, we can refer these textbooks. Thank you.